Adding and subtracting fractions. Simple, right? Like 5th grade all over again. But with like barbed wire, you know, at the top of the fence. Because we're going to put X's in there, like barbed wire X's. So what I thought we should do first is look at some 5th grade problems, right? The old school fractions. And so at this moment that I'm making this video, I have no idea how long it is, but you guys already know that, right? So I'm hoping to make this a short one, like 10 minutes tops, right? So when it comes to fractions, I like to think of fractions comparable to money, okay? You know, you have the word denominator with a fraction, right? Denominator. And in order to add the two fractions, as you all know, and I asked second period, what do you have to add fractions? Common denominator, right? Second period pre-cal, let me hear you. Woo! Forgot to ask that in first period today. So first period pre-cal, let me hear you. Woo! Okay. If you think in terms of money, we use the word with currency, denomination, right? Like you have different denominations, like the dollar, the US dollar, is a different denomination than the Australian dollar. All a very different denomination than the euro. All very different denomination than the pound, right? And if you go to other countries that have other names for their denominations, those are different denominations as well, right? So if you have one American dollar and 1 euro, $1 plus 1 euro does not make 2 duros, you know? You have to convert from one denomination to another. You have to have the same denomination, same denominator. Okay, so if you have a third of something plus a third of something, well, those are already the same denomination, right? The denominator is the same amount. So third of a dollar plus a third of a dollar is 2/3 of a dollar. So you add the numerators, you keep the denominator the same, right? But first, the denominators have to be the same. So like on problem 2, when you look at these fractions, you can automatically tell, hey, the denominations are not the same, right? They're different denominators. So if you have a third or 1/12 of a dollar and a third of a euro, you have to do something to convert the third euro into dollars, right? Into twelfths. You have to convert 1/3 into something about 12. And so to do this change of denomination, the big deal is common factors. Factor, factor, factor. Mother factor. Find the factors. And if you need to, maybe you take 12 and write it as 4 times 3. And so now you realize, oh, this 1/3 over here needs a factor of 4 in the denominator. Right? If I multiply the denominator by 4, the denominators are equal. They are common, right? They're the same. But when it comes to changing a number, you're not allowed to multiply by a 4 in the denominator. When it comes to changing a number but not changing it, you have to multiply it by a 1. So what number goes in the numerator to keep that number a 1, right? 4 divided by 4 is 1. All I'm doing is multiplying by a weird kind of 1, funky kind of 1. And so 1/3 is actually 4/12. And I would bet that a problem like number 2, most of you could probably very easily just go, oh, it's 4/12 plus 1/12, 5/12. I'm not saying that you all must write these steps here, okay? Like I said, we're going back to 5th grade. Ideally, you can do this problem from 5th grade a whole lot faster, you know, nowadays. But I'm breaking it down into smaller bites because when we get to the ones like you see number 4, all of a sudden there's going to be variables, right? And with variables, it's more exciting and more complex and it's going to take more steps. So 1/12 of a dollar plus 1/3 of a euro is like having 1/12 plus 4/12, which is 5/12 dollars, right? We're converting the denominator or denomination to being the same. Sometimes, number 3, you have to change both denominators. So on problem 2, we looked at the factors of 12 and we realized, oh, there's a common factor between 12 and 3, right? And I had to only change the 3 by a factor of 4. So I only had to change 1 fraction. And so the point of doing that is you want to try to get the lowest common denominator. Obviously, a common denominator between 12 and 3 would be 36, right? But that's not the lowest common denominator. So if you use a bigger common denominator, it's actually going to create a whole lot more math for you, a whole lot more work, sometimes a whole lot more confusion, especially when we're dealing with variables. You want to try to use the lowest common denominator. So 3, same issue. 12 and 21, they look alike. But 12 is really 4 times 3, and 21 is really 3 times 7. Right? So they have something in common. They have a common factor of 3. So the lowest common denominator is 28. Or sorry, 28 times 3. I got to multiply 4 times 7 times that extra factor of 3, right? So that's going to give us 28 times 3 is 84. But when you see the factors like this, right, 4 times 3 and 3 times 7, what this is telling you to do is, stop it, is you only have to multiply the first fraction by what number? The first fraction has a factor of 3 already, which the other fraction has, but it does not have this 7. So I got to multiply by 7 over 7, right? And then the second fraction is like, yo, bro, I got you. I see your 3 and 3, and now I see you have my 7 because you have a 7, but I need that 4 right there, right? So we're trying to make the denominators the exact same number of factors. Obviously, if you could reduce any of the fractions first, I would reduce them first and then maybe do this. It might save you factors, but I put a 7 and 5 on top of the numerator on purpose, so there wouldn't be any like factors that reduce out of 12 and 21. Now you just get to do the math. What's 7 times 7? 49. 49 minus, what's 5 times 4? 20. And the common denominator is that 84 that we were talking about a minute ago, right? It's 3 times 7 times 4. 21 times 4, 84. It's the same thing as 4 times 7. I'm sorry, 12 times 7, 84. That's the same thing as 28 times 3, 84. And then when I subtract 49 minus 20, so addition and subtraction, they're both going to like, live together. Some of these problems are addition. Some of these problems are subtraction. We have to be very careful with the subtraction ones in a minute when we start using variables, because you sometimes have to distribute the minus sign in between the fractions when you have more terms on top. So again, the first 3 problems, I shouldn't have even had to explain them, but I'm trying to use words that we're going to use now with variables, and just reviewing. Obviously, 1, 2, 3, you could type in a calculator and hit math frac, and it will give you the answer in reduced form, right? When you're dealing with variables, not so much. And this is tough because this is one of those like upper levels of math things. Sometimes, and I actually have an application problem down here, the last one. But a lot of times, the question's asked, when are we ever going to do this? And so this process of adding fractions together with variables is not like it's a tool that is used within much larger worlds. It's not like you're going to have a job where your boss says, I need you to add all these fractions together before you go home, and you're adding variables and stuff. Like, this is just something that we do mostly because it's fun. I mean, we're having a blast. Isn't this awesome? We're having so much fun. So number 4, I tried to make it look a lot like number 1. 1/3 plus 1/3, 2/3. So what's 1 over x plus 1 over x? In order to add them, you have to have a common denominator. Are your denominators the same? Yes. So then you can just add straight across the top. Right? 1 plus 1 is 2 over x. It's great when the denominators are already the same, right? When denominators are the same right off the bat, you're good to go. Obviously, the denominators were the same only in problem 1. And then in problem 2, things got more exciting, right? Remember, in problem 2, we had one fraction that contained a factor of the other fraction. The 2 fractions had something in common. They were not common denominators, but they had a common factor. 12 and 3 had a common factor. So number 5, same thing. We can scroll to here. Let me think. I put a 2 over x, kind of like the answer we just got. plus a 1 over 3x. So when you look at these two denominators, are they identical? Are they exactly the same thing? Because that's what it means to be common. And they are not, right? They are not identical. They're not exactly the same thing. They're very close because one contains a factor of x and the other has a factor of x. They both have a factor of x. But the issue is the 3, right? This 3 is like, hey, I'm here. And the other guy's like, dang it, I don't have one of those 3s. I like that 3 there. It looks really good sitting next to that x, you know? So it's a matter of making each of the denominators look exactly alike. Pair them up so they are the same. So the first fraction needs a factor of 3 in the denominator. So once I write the 3 down there, like, cool, I did it. I have them common denominators. The issue is I can't just multiply the denominator by 3. I have to also multiply the numerator by 3 because 3 divided by 3 is 1. And when you multiply by 1, you don't change the identity of the fraction. The fraction is still inherently the same thing. You're not allowed to just make up a whole new fraction. That changes the problem. But 6 over 3x, oh no, my tablet dropped. 6 over 3x is the same as 2 over x. And that's what I have to do is keep the same identity. 1 is, oh, come on, is the identity element for multiplication. That's the fancy words that we use. I'm going to have problems with this. I've already said this before in the last video. So 6 over 3x plus 1 over 3x. Now I can add them together. What is 6 plus 1? That makes 7. Common denominator is 3x, right? You don't add 3x plus 3x. You just add the numerators. Once the denominators are all the same, you add the numerators. Or subtract them depending on what the problem is. Okay. We got 1, 2, 3, 4, 5-ish problems. Getting more and more involved, but hopefully my computer can keep up. Come on, baby. Give me like 10 more minutes. Number 6, I tried to think of two fractions that looked a lot alike, but were not exactly the same. Okay, x plus 1 and x minus 1 are completely different factors. So as we've been saying here, we're looking for factors. 3 is a factor on problem 5, and x was a factor on problem 5. 3x was the common denominator. On number 6, these are two completely different factors. So the first fraction, I know it's like x plus 1. It makes you feel like it's a lot like x minus 1, but they are totally different, right? Matter of fact, just let x be a number like 7. What is 7 plus 1? That's 8. What is 7 minus 1? That's 6. 6 and 8 are completely different numbers, right? So x plus 1 and x minus 1 are different creatures. So what you have to do here is you do have to multiply the first fraction by x minus 1 over x minus 1. Bless. There we go. Can you read that? The first fraction needs the same factor that the other fraction has. And simultaneously, the second fraction, it needs a factor of x plus 1. So now looking at the two fractions, they are both x minus 1, x plus 1, x minus 1, x plus 1 in the denominator. Okay. Now I didn't have to factor anything here. They were already given to me as separate fractions with different factors, right, in the denominator. It's kind of like if I were to say add 1/3 plus 1/4. I didn't do one like this at the very top, and maybe I should have, but 3 and 4 don't have any common factors, right? So you would multiply the 1/3 by 4 over 4, and you'd multiply the 1/4 by 3 over 3, right? You have to change both fractions. The previous examples, we hadn't had to do that yet, right? So I'm changing both fractions to get that common denominator. Now, these are my suggestions to you for what's going to happen next. My suggestion to you is do not multiply the denominator out, okay? Leave the denominators factored. The issue is, in the end, sometimes the fraction reduces. If the fraction is going to reduce, it's only going to reduce like we did on the last assignment, right? The multiplication and division worksheet. You only reduce the fraction or simplify the rational expression, right, when you have common factors on the top and the bottom. So you want the denominators to be factored. Now on top, we are going to have to do some math. We are going to have to distribute x times x and x times -1 and get x squared minus x. And that's something that's kind of new and exciting. We haven't had to do a lot of that yet. Maybe any minute here we'll have a FOIL problem show up. Did I make a FOIL problem? Daggone it, I sure didn't. And maybe at the very end we'll have to practice FOIL just to remind you. Distributive property, that's a thing, okay? Likewise with the second fraction, you have to distribute 2 times x and 2 times 1, which is 2x plus 2. Right? So what I have just done is change my 1/3 to a 4/12, and I've changed my 1/4 to a 3/12. Right? I've converted both fractions to having the exact same bottom. Right? Look at my bottom. Look at my bottom. Do you see my bottom? See how my bottom is the same as that bottom, right? We have two of the same denominators. And so now it's possible to add them together, right? Now I would add across the top all the things that are alike. So the two denominators get put together, just like on the last problem, right? It was just all over 3x, all over 3x on number 5. On number 6, it's all over x minus 1, x plus 1. And I'm not going to FOIL that out. I'm not going to multiply x minus 1, x plus 1. I'm hoping you guys remember FOIL. What's left is now I have x squared minus x plus 2x plus 2. So red and blue make purple, right? Let's do purple. X squared plus x plus 2. X squared minus x plus 2x makes plus x plus 2 at the end. This is tough because a lot of times, in class, people would say, hey, I have a question, but I can't wait for y'all to ask a question or else the video would never end. And then I would have to post a never-ending video for you to watch so that you could see what you needed to ask. And then you'd have to go back in time and ask the question while I'm making the video. It's just getting complicated. It's your kids, Marty! Your kids. Anyway, x squared plus x plus 2. Now, does that factor? Can we factor x squared plus 2x plus 2? At first thought, you might think, oh, yeah, because x plus 1 times x plus 1. Well, it's not, right? Remember, to factor this, you have to think of two numbers that multiply to 2, which has to be 2 and 1 because 2 is prime. And 2x plus 1x, when you FOIL, makes a middle term of 3x, and here the middle term is 1x. So we're good. The top doesn't factor. What does that mean? That means we're finished. That is the answer right there, right? If the numerator factored, then I could cancel something out maybe, with the denominator if there was a common factor. But there isn't a common factor. This numerator doesn't factor at all. Now, does that mean you could go ahead and FOIL the denominator? Sure, you can. I would bet that on the answer key to this question, like if this were from a book, they would probably FOIL the denominator. I'm all about you not FOILing the denominator. You can if you want to. It'd be x squared. Oh, can't write with the eraser. Silly Mr. Quirk. All over x squared minus 1. So that's FOIL, right? First outside, inside, last, we FOIL. I think I talked about FOIL in the last video because I was factoring and it was like unfoiling, right? So I assumed you all knew how to FOIL, but we haven't had any problems where we had to FOIL. Anyway, either of these answers is fine, okay? I'm cool with it. I like to box in my answers with yellow. So then number 7. Number 7, we're finally getting to a place where, let's pick a new color. Let's pick green. Notice on 7, the denominator of the first fraction is not factored. We have to factor it first, right? We have to factor x squared minus 4. And it's, x times x is x squared. Okay, now rewrite the problem for a second. How does the denominator factor? This is, again, difference of two squares. Can you think of two numbers that multiply to -4, but they add to 0 because there's no number in the middle, right? So those two numbers would be x plus 2 and x minus 2 are my factors because -2 times +2 makes -4, and -2 plus 2 would make 0, right? When you do the FOIL, you get a -2x and a +2x on the outside and inside. They cancel out. So again, we have difference of two squares. X squared minus 4 is a difference of 2 squares. My favorite kind of factoring is a difference of 2 squares. So now when you look at these two fractions, you can tell the denominators are not the same from the beginning. But when you factor is all about factoring. When you factor that first fraction, now you see there is a common factor. They don't have common denominators, but they share a common factor, right? It's kind of like you and your friend, maybe your name is Marty and their name is Matt. So your names are not common. You don't have the same name, right? But you have something very common. They both start with the letter M, right? You have a common initial, same initial. So they both have an x plus 2, but the first fraction has this x minus 2. And the second fraction is kind of jealous, right? The second fraction is like, honey, look over there down the road. Look at our neighbors. Look, they have that x minus 2 out front, just like we've got an x minus 2. I like that, the x plus 2. I like the way that looks. That x plus 2 looks really nice out there. But look, honey, look, they have an x minus 2 factor. Look, it's sitting right next to their x plus 2. There's an x minus 2. I want that, honey. I want that x minus 2. It looks really nice, You're like, oh, honey, really? And she's like, get that for me. And of course, you're going to go get it for her because you love her. And you do think the x plus 2 and the x minus 2 look nice together. And so in order to subtract these two fractions, you have to change the second fraction to having the same denominator, right? But you don't know that they're the same unless you first factor every single part that needs to be factored, okay? If you were to just multiply the first fraction by x plus 2 over x plus 2 and the second fraction by x squared minus 4 over x squared minus 4, okay, that would not be wrong, but you would not be using a least common denominator, okay? It's kind of like if you did 1/2 plus 1/5, and you thought, oh, this is really 50 out of 100, and this is really 20 out of 100, so this is 70 out of 100. Well, now you have a fraction that needs to be simplified. Times by 20, right? 5 times. All of a sudden, I thought maybe I did the second fraction wrong. So now I can reduce, to 7 out of 10. I can reduce this fraction, and it's 7 out of 10, right? Simplify the rational expression, like we did in the last assignment. This is really 5/10 plus 2/10 makes 7/10. So it's just a little bit easier if you use the common denominator first. No, I'm sorry, the lowest common denominator. I don't want to multiply the left side by the right fraction and the right side by the left fraction. You have a much bigger problem. Now, this is a part, I made this problem up on purpose, this one. There's a -3. I see a lot of mistakes with the -3. You have to make sure you include the minus sign when you distribute the 3, okay? You want to distribute -3. This is why a lot of your middle school teachers might have told you, change your subtraction to addition of the opposite. If it helps you to put the negative on top next to the 3, that way you don't forget about it or lose it, you can change a subtraction to addition of the opposite value and distribute the 3 in there. Or just, keep them separate and distribute as a negative sign later. But I like to do it all at once. So I end up with the first fraction is 4x over x plus 2, x minus 2. Now what I'm going to have is a plus, same denominator, x plus 2, x minus 2. And I'm distributing the minus sign. So what is a -3 times x? -3x. What is -3 times -2? And as sure as I'm saying it right now, right here now, as sure as you're darn tooting, as sure as I'm saying it, okay, at least one of you is going to make this mistake. It happens so often. It's so easy to do. You'll look at the negative and put it with the x. People will distribute the minus sign to the first term. But a lot of mistakes that I will see with this kind of problem is you'll have a -6 at the end, okay, because you'll do 3 times -2. Forget to make the -2 a negative, which is plus. 3 times 2 is 6. So final answer. Final answer here is I go across the top. What is 4x minus 3x? That's x plus 6. And then the denominator is x plus 2, x minus 2. Can you go back and rewrite the denominator as x squared minus 4? You can FOIL the denominator. It's fine to do that. Like I said, if this is like a question in a book, you know, the answer in the back of the book would probably FOIL the denominator and distribute it back. I'm cool with just leaving it factored. So if it's like a quiz or a test, you can leave it for me either way. Fractions, 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 right? This is really like you go doing multiplication and division. I think you tend to be like, okay, I think I got that. That's not so bad. Addition is like way worse. It's way more complicated. And so maybe watching this video is good. We'll have time to practice tonight and tomorrow. And I will see first and second period again on Wednesday. We can go over more questions and practice more stuff before I move us on to the next thing. We really have to practice this addition stuff. I pulled up an old worksheet because I wanted to get to like a word problem. And I saw some of these on here. And honestly, we actually did one like number 8 already, I think. Yeah, number 6. Number 6 that we just did right there is very similar to number 8. I might skip number 8 so your video can be shorter. As a matter of fact, if you want, pause the video and work out number 8 on your own. And I will quickly rush through it and see if I can get it right without screwing up. What's different about 8 is the minus sign. Again, I put another negative in there. That's why I picked it, now that I remember it. So, again, you can pause the video. And I don't know if anybody ever does this, but I do this a lot. If you have YouTube videos that you have to watch and you don't really want to watch them, right? You can put the video on like double speed. So right now I'm talking like this, you know, like Alvin and the Chipmunks speed. And honestly, I think that's kind of nice. It makes it all sort of go faster. Watch a 30-minute video in half the time, right? Right now it's on pause, so you have no idea that I'm saying all this. Speaking of pause, you know, a bear walks into a bar, and the bear's like, "Hey, bartender, I'll have a beer." And the bartender's like, "Sure, buddy, but what's with the big paws?" And he says, "I'm a bear. I have big paws." It's funny, isn't it? So right now you're just working this out on your own while I'm working it out. Ideally, I should have worked this answer out first. That's what a good teacher would have done. I would have just already had this answer here. Boom. Then I could have brought it up and we'd be done. We'd be saving time right now. But right now, if you listen on double speed, just going this fast anyway. So notice on number 8, there's this minus sign. So how do we handle this minus sign? Again, change this minus to addition of the opposite. Make 4 negative. That might help you to remember to distribute. So this is plus now. Negative 4x minus 20. Negative 4x minus 20. It's very possible that I screw one of these up. You know, that would be terrible. That's what happens when you make up a bunch of problems and you haven't worked them out yet. So now I go across. Negative 3x minus 4x is negative x. What is 3 minus 20? Negative 17. All over x plus 1, x plus 5. Three minus 4, negative 1. 3 minus 20, negative 17. And there's no common factor there, right? Nothing cancels out on the top and the bottom. You could say, well, on top, can't you a negative 1? You can factor out a negative 1. Like you can pull a negative out front. And that might be how this problem is written. Not with a negative 1, but just a negative sign out front. But notice x plus 17 doesn't cancel any of the other factors on the bottom. X plus 1 and x plus 5 are different. I picked number 9 from this worksheet because of it has 3 fractions. And they kind of look similar. A couple of them have some 2's in it. A couple of them have some x's in it. Again, the issue is, I'm sorry, even I'm getting bored with this. Sorry, you guys. Definitely put me on double speed. The first fraction, I'm gonna write this over. So it's 1/2 plus 2 over x minus 3 over xx. So again, going back to your neighbors, right? Honey, our next door neighbor has an x now. I want to get an x, right? And then your next door neighbor's like, dang it, lady. I was happy with my, oops, that can be cut. I was happy with my X that I had out front, and now you have one as well, right? And then the third fraction is like, hey, I have an x as well. So all three of them have an x now, right? The second fraction is now saying, you know what? I like that 2. That 2 looks pretty good. I'm going to get me a 2 in my denominator. So, I can match my next door neighbor with a 2x. And notice these two fractions in the front, the first two fractions, both have a common denominator of 2x. The last fraction is now going, dang it, guys. I want one of those 2s. The 2 looks pretty nice, right? So put a 2 out there. Now, all three of them have a 2. All three of them also have an x. But the first two fractions are now feeling a little bit inadequate compared to the third fraction. Because the third fraction's got that, like, big x. It's got an x squared, right? There's 2 x's, xx. So by changing all three fractions, they now have a common denominator of 2xx, or 2x squared, right? That is the least common denominator, 2x squared. So I can put all of them over 2x squared. The first fraction was x times 1, which is x squared. The second fraction is 2 times 2 times x, which is plus 4x. And the last fraction was minus 3 times 2, which is minus 6. And ta-da! X squared plus 4x minus 6, all over 2x squared. Common denominator. At this point, you could try to factor the top. Can you think of two numbers that multiply to give you 6? Well, there's 2 times 3, but 2 plus 3 and 2 minus 3 don't make 4. And there's also 6 times 1, but 6 plus 1 and 6 minus 1 will not give you 4. So this numerator does not factor as quadratics tend to. It's just done, just like that. It's done. So that's number 9. I don't know if I did that too fast, but that's how it would go. If you need to, you can go back and watch the video slower. Take it off of double time. You used to be able to go back to what's your name? See, it doesn't do it anymore. I used to be able to see how long the video was. Like it would do it in real time. Oops. Now it doesn't do that anymore. Changed it, I think. I don't know. So I picked up this problem because it was like, when are we ever going to do this? Okay. When are we ever going to have two fractions with x's and we have to add them together? That's a good question. It's a valid question. Maybe never. So I did find something about resistors, right? Connected in parallel, your total resistance is 1 over 1 divided by R1 plus 1 divided by R2. So the resistances are R1 and R2. Some of you guys are probably in physics this year with Coach Thompson or Mr. Gosh, who else has physics nowadays? We hired new physics teachers. Mr. Lloyd teaches physics. Mr. Cox retired. I don't know that Mr. Richards teaches physics. So I don't even know who the new physics teachers are. Mr. Smith taught physics last year and he retired. So good luck with physics. That's complicated stuff. Notice number 17, they want you to simplify this complex fraction. I also picked this one because we haven't done complex fraction yet. Complex fraction is when you have fractions inside a fraction. Doesn't that sound great? So on 17, right, the first thing you want to do is ignore this 1 divided by. Pretend like that's not even there. What you've got to do is get the 1 over R1 plus the 1 over R2. You've got to add these two fractions together first. You're going to pretend like this 1 divided by is not even an issue. Okay. How do you add two fractions? You have to have a common denominator. Well, common denominator here means you got to multiply the first fraction by R2 over R2. Any Star Wars fans out there? R2. And then you need R1 times R1 in the first fraction, right? R1, R1. So my new denominator, 1 over, is R2 plus R1 over the factor R2 times R1. And obviously, because multiplication and addition are both commutative, I could turn these around if I wanted to and write it with R1 first. R1 plus R2 over R1 times R2. But now I'm dividing. So I'm dividing this whole thing. And we talked about this in the last unit. So complex fractions are fun because they also involve like what we did previously in that you're dividing, so you have to multiply by the reciprocal. So what's the reciprocal of R2 plus R1 over R2 times R1? Well, that would be R1 times R2 over, what, maybe I should write it the same, sorry. R2 times R1 over R2 plus R1. And that's it. You're finished. And those are the worst 2s ever. And you all might be thinking, bro, I've been finished for like 10 minutes. You like went way too long. I'll probably do more with complex fractions, okay, in class on Wednesday. This worksheet that I made for you guys that I'm going to post right now, it has 3 complex fractions at the bottom. And I should have put a complex fraction like with some more examples on here, but this video is long enough and you wouldn't want me to do it. So I might have to practice some in class. Forgot to add some extras on here, but that's it right there. R2 times R1 over R2 plus R1. Because 1 divided by that is the same thing as 1 times its reciprocal. So when I do 1 times the reciprocal, I just get that, the reciprocal. As I was saying a minute ago, this might more commonly be written if this is in some sort of like electrical engineering book. You would think they'd probably do this in a like kind of chronological order. R1 times R2 divided by R1 plus R2. Those are exactly the same thing, right, guys? Look, now it's like a TIE fighter. Okay. Then part 18 says, find the total resistance in ohms if you have a 4 ohm resistor and a 2 ohm resistor. So might as well knock this out and be done. 18, right? What is 4 times 2? 8. What is 4 plus 2? 6. What is 8 over 6? 4 over 3. Ta-da! We're going to use improper fractions all day long. Do not make that a mixed number. Don't make it 1 and 1/3. That just doesn't happen in upper levels of math. We don't use mixed numbers. What we do use in upper levels of math is this whole adding fractions thing. Okay, in AP Calculus, there will definitely be adding fractions, multiplying by reciprocals of fractions. Having to simplify fractions is like a skill, a tool, that you need. That it's just expected at certain times. That you're going to have to do it. So for now, we got through a whole lot of notes. I need to shut up. I'm going to post these problems. I would suggest watching the video in double speed. I might put that on the Google Classroom part. So I probably sound funny that way. All right, so everybody have a good one. See you later.